I'm here to talk about multi-arch KubeVirt and Containerized data importer on multiple architectures, obviously. My name is Fillekes. I'm at IBM Systems, working as a Red Hat partner engineer for about 5 years now. Been working on this project for about 2 years, and today's discussion regards the upstream open source aspect of the project only, so that my boss doesn't have an aneurysm. Okay, what is KubeVirt and Containerized data importer? KubeVirt is a way to run KVM virtual machines in a container. This is often used in Kubernetes clusters. You can stop and start virtual machines with a YAML file, reconfigure, relaunch existing VMs. It's got a nice templating feature. Containerized data importer uses persistent volume claims on disks for KubeVirt VMs by way of data volumes, and it can also import, clone, and upload your attached storage. Note that CDI import, clone, and upload are supported for VMs which are, among other storage options, stored externally in VMware installations via the Virtual Disk Development Toolkit on x86 and on x86 alone. This will come to be important in our next slide. What do I mean by different architectures? I mean your x86 machines that are in widespread use in data centers across the world. They run Linux, RH Core OS. You've got a lot of VM templates, a lot of VMs for them, container registries galore, and Kubernetes obviously runs really well on these. ARM64, you've got all of those things, except also they run at about half the power per CPU cycle. They're a reduced instruction set, run on little endian encoding, just like x86. And these are your usual Mac, Raspberry Pis, cell phones, and edge devices. So this is out at the edge very often, but also in big server rooms as well these days. Okay, what is S390X architecture, also known as the IBM mainframe? And it's like, do we use IBM mainframes anymore? And the answer is about 97% of your credit card transactions are processed by an IBM mainframe. So yes, they are in wide use. They also run at low power. They also are a reduced instruction set. They're big endian, which is porting issues. They run, and there's many features that, in addition to porting, say, Kubernetes and or KubeVirt and or CDI to the S390X architecture, you've also got all these other wonderful features that you want to enable in the course of that, so that if you get a specialized VM or develop a specialized VM, it runs easily on there. Okay, so what do I mean by multi-arch? Okay, there's multi-arch, which means that you can run this on different machines with different architectures, right? There's also, if you have a cluster, you can, a Kubernetes cluster, you can have worker nodes that are on, maybe your control plane is on x86, but also you might have some worker nodes that are ARM. You might have some worker nodes that are on the mainframe. So this is, opens up some interesting possibilities, especially in that you can pull in VMware virtual machines into your x86 nodes, run them, take them apart, put them back together, template them, and convert them to S390X or ARM virtual machines, which is not something you get with VMware, and it also gives you a nice management platform in order to do this in a regular way. You don't have somebody off in a room somewhere doing a VM conversion and then here's your VM. It's transparent, it's reproducible, it happens, you can, it's declarative, it's got a YAML file associated with it, you got all those things. So I will, do we have any questions? Questions? Okay. This obviously is not me alone. This is a cast of thousands. It's Red Hat, the IBM Biblian Lab in particular, where I get to go next in my travels, and Ryan Halsley from NVIDIA, and ARM is involved as well. And also, because this is an open source project, you too can contribute. Let me just go back since I've got 10 seconds, I want to mention that related projects are Istio and node feature discovery. 3, 2, 1. Thank you very much.